Today I want to talk briefly about a network that I build every year at an event called Burning Man. Burning Man is held in the desert. It's a city that has roughly 70,000 people, and it has a pretty large infrastructure on the network side. And hopefully we'll get some slides here at some point. Hey, sweet. Okay. Oh, okay, great. I even get speaker notes. That's awesome. Okay, so we'll just quickly a refresher for folks that may be outside of the Bay Area. Burning Man is held in the northern Nevada desert. It's about 2.5 hours from Tahoe or the Reno area. This is typically an hour-long talk, so I'm going to go really quick. Again, 70,000 people on a dry lake bed. It's a fully functioning city. So most people think of Burning Man as it's just like a festival or a rave or a party or something like that. But it's a real city. And everyone has a different view of what they view a city as. I look at cities by topology or the infrastructure that's within that city. So we don't have a network that has lots of 100 gig and tens of thousands of routers, but we're the sole ISP for those citizens and the departments that run the infrastructure for the city. So we take our jobs pretty seriously. I started going in the mid-90s, and I took several years off. And when I came back, I saw a lot of problems that had kind of creeped up over the years. So one of them is large layer 2. I think that's been kind of beaten in everyone's head this morning that layer 2 is bad. Brent had a couple good quotes there that it's just the architecture or the application is flawed if you need large layer 2. And thankfully, with a lot of the cloud applications we have today, developers are getting used to the limitations and are used to layer 3. So that's really exciting. But for us, layer 2 is a big problem because a lot of our links are wireless and that doesn't scale really well. Multiple layers of NAT. NAT's really evil. It's really evil when a truck roll is expensive. So for us, it's very expensive to actually get in a truck or get on a bicycle and go out and go to a customer. So having anything that impacts the customer around reliability or routing or making the application work is paramount to us. We don't want to roll a truck if we can avoid it. Again, when I came back, there were kind of two different units. There was one department that was focusing on participants, the camps, and the other that was focusing on the internal departments or teams. So it's things like commissaries, law enforcement, media mecca, artery. There's something like 70 departments within Burning Man, so it's a pretty big differentiator there between the participant camps. As you've heard, again, a lot of folks talking about tribal knowledge to get things into a central source of truth. We didn't have that, and lots of single points of failure. So when I came back, one of the things that I try to do is apply some of the lessons I've learned in the real world. And I'm not a big blogger, and I don't do a lot of self-promotion, but if you've heard of Tumblr, if you have any kids, I built that network in that data center. If you heard of Square, the little thing that plugs into your iPhone, I was employee number 8 there. So I've built pretty large networks that had to be reliable. And so I tried to apply a lot of that knowledge in a network that was very dynamic. And so one of them is unifying the team. And I think that really goes to the heart of today's conversations, is that when you look at DevOps, it was uniting kind of operations and development teams together. Now, whether that was through tooling or through process or for just making the product more cohesive between those teams, it brought them together. And I think with the network for DevOps movement, we need to bring those teams together and bring those silos down. And one of them can be around how you're using resources across the organization. So for us, one of our resources was RF spectrum. So bringing these teams together that were serving different customers, we could utilize that limited spectrum more efficiently. So that was really important for us. The other thing is using stuff off the street, right? So COTS is a really old term. It means commercial off the shelf, right? So this is stuff that you can buy that has support and you can escalate to. And I can't iterate how important that is for this SDN movement. If you can pick up the vendor and call them and they support what you're doing, that's really powerful. So in the case of Cumulus, right, they have a whole suite of software that they support. Same with Juniper and Cisco and Brocade, everyone else. They have picked various DevOps tools that they support. Make sure you apply one that you can get some support on and you have a support system around that. And again, standardized offerings. We had all these different configurations we were offering people. And so if you're going to automate, one of the very first problems to solve is what I call the layer 1 and layer 8 problem, right? If you can solve the physical problems and the people and the politics, everything else, routing, automation, monitoring, is really easy. And you can really drive this message home with the lessons we've learned at Burning Man. So one of them is that we have a consistent service that we deliver to different departments. You get a piece of Ethernet, it has internet on it. That's it. If you're a participant camp, you buy this radio, you aim it to the center camp. That's all you do. Like, it's very consistent. Another rule we made is we route everywhere. You would think that's overkill for something like a temporary network that's in the desert, but it's actually very scalable. It's very easy for us to debug problems. Another thing we do is we don't use any 1918 at all. So we actually use an RFC. There's a /10 that you can use, and that's very useful because a lot of people bring equipment that has viruses or worms or problems on it. And it's 192.168. We can say, that's not our equipment. We don't use that IP space. So again, routing is very powerful for scaling and again, pointing where the blame is of the problems. And to the meat of the conversations today around automation. We started really small. We started initially with just routers and switches. We've been using Automation Suite for about 4 years now. And then we grew. So today, a user literally types in make, and that does not only every switch and every router config, it does every radio, it does our forward and reverse DNS, it does our smoke ping, our RD tool, our pager system, everything. So it's very scalable for adding folks into the team because we started initially with just a small scope of automation and increased that to other domains. So on the automation front, we've been doing this for a while. Originally, we had a bunch of stuff in basically common eliminated files and some Perl scripts that just pulled stuff out. Originally, that was geared for just generating our Nagios config, so it had like X and Y coordinates, parent-child relationships, that sort of thing. And we extended it to have IP addresses and whatnot. And then we moved to YAML. That was really hip. So YAML was the cool place to store our configuration data, but we still needed to template it out to devices. And so we wrote one-off scripts for each of those. And finally got to the point where we had like 6 different scripts, one for DNS, one for switches, one for routers. That just wasn't really scalable. So we looked at, some sort of open source that would allow us to do automated config deployments. And at this time, Puppet and Chef were gaining traction, but had pretty much zero experience outside of the compute space. They're really focused on managing servers at that point. So we ended up using some software called NCG. And the bummer about NCG is that it actually solves a lot of these problems, but it was way ahead of its time. I like to call it like the next step of network automation software because it was just way ahead of its time. And the gentleman that wrote the software, he actually works at Google now. So he applies some of the lessons he's learned there. But it never really took off, but we still use it. And it's called Network Configuration Generator. And it's basically a bunch of Ruby. So you have input files. The input files are just tab eliminated or any sort of flat file types of files that you would have like CSV, tab eliminated, spaces, that sort of thing. Then you have like a markup file, kind of like an M4 file, where you can take some of these variables and iterate on them. So one example of that is that for all of our VLANs, we'll use that as like the 3rd octet for IP space that we're natting. And then you finally have Ruby ERB templates at the end. And again, this is normally an hour-long talk, so I'm not going to show you code of that, but I will show an example of this workflow that everyone's been preaching this morning can actually be done. It can be done in the desert with volunteers that are dehydrated and distracted. So if you can do it there, you can do it in your business or your day job. And so here's a classic example. So we upgraded a vendor. This is Juniper's EX2200. So they've got a switch. We wanted to do DHCP relay. We upgraded to a new version. The syntax had changed. And so I had to break out PCAP and Wireshark and figure out what broke down there. And finally, I found out, we're out of battery. Yeah. I found out that we were, that they had changed the syntax for the DHCP directive. And so I was able to basically look at one of our templates and say, okay, because I know the make of the configuration that we're deploying, is it a switch, is it a router, I can just basically add in our template, if it happens to be a device that's a switch instead of a router, do a slightly different config. So here you can see really basically that they changed the syntax on us, but I could easily add, okay, well, if the model number has changed, add this line and add this other line. So it was really simple where we found a problem, we were able to debug it and then roll it out within literally a matter of hours from when it was reported to debugging the problem to pushing out the config. And this is all in Git. And so everyone, gets an email or alert when this gets pushed out. And Git works really well for us because the internet's not necessarily built. We build that infrastructure, everything from putting a grounding rod in because there's no grounding bar, getting power plumbed, aiming an antenna. It's a lot of physical work. So great thing about Git is that it's a distributed offline database. So we all have a Git checkout. We're all making changes to the network, and we can all check it in when we're back online. So it scales really well for us. So again, I just wanted to show a real-world example of what everyone's been preaching pretty much all day here around the fact that you can use a single source of truth. You can use version control systems. You want to spread that knowledge. It can be done. Like it's totally possible to do that. So just kind of wrapping up here to try to be under my time limit. Automation isn't easy. The data modeling is really critical. And so for us, again, we focused on switches and routers initially, and then we grew out from there. So your requirements may be different. We never thought of billing as a requirement for us, but as our bandwidth has been tapped out, we added things like categories. These are staff camps, these are participant camps. This is critical infrastructure, such as this is a VoIP, so they can call 911 or get a live flight, or this is someone that's just ordering ice, right? There's different priorities for us. So always think about data modeling as something that's going to change over time. I think as the gentleman from Cisco mentioned, whatever you design today is going to change in the future. So always be flexible on changing that modeling. Second real big lesson for us was single source of truth is incredibly powerful, and you should be very flexible about that, right? Everyone knows that having the Excel spreadsheet that floats around doesn't scale, but you may not necessarily want to sign up for a fancy IP management software. Maybe you have a wiki, maybe you have a CSV file that's checked into Subversion. It doesn't matter, but as long as there's a single source of truth that's scalable to everyone in the organization, that's extremely powerful. And when I mentioned stress level in there, it's really that. Find what works for your organization. You may choose to use some fancy management suite that you already have that exists, or it may just be a flat file, but make sure it's something that can scale within your team. And again, starting at the physical layer and the people and political layers. For us, the physical layer is most of our work. Unlike in a data center, we literally do put the grounding rod in, we crimp the cable, we aim the antenna. We don't have time to do config, right? We literally have enough time to copy over a config and go to the next site. And so for us, I think the lesson learned there is that if you started optimizing some of your physical problems, and whether that's a common cabling scheme or consistency in hardware, and then you look at the process around people, what are the average tasks that they're doing? Is it handing out static IP addresses? Is it moving VLANs? If you bring those together, naturally everything else will come out of it. So for us, it was building a network that was routed, it was using a particular automation suite, and it was really to be efficient. And in fact, we're so efficient now that they actually give us pagers. We have on-call, like at the desert, because we don't have anything to do during the week anymore. So you can get to that nirvana, it just takes time. Thank you.